Hello and welcome to today's webinar, Data Management for Building Component Manufacturers. This webinar is brought to you by Applied Software. My name is Caitlin Dunn and I'm pleased to be your moderator today. We encourage you to take advantage of our fully customizable webinar console by clicking on the icons at the bottom of your screen. You can resize any of these widgets during the presentation. Click the Help widget if you need assistance. Then you have the Slides widget that contains the PowerPoint used for today's presentation. The media player allows you to control the volume. After that, you have the Q&A widget where you can type in questions and comments throughout the presentation. We'll take time to answer questions during the end of today's webinar. We're excited to connect with you further. Please take a moment to introduce yourself. For other questions or comments or to request more information, click on the next widget to send us an email. Next is the Facebook widget. Like our page to catch up on the latest trends, training opportunities, and much more. You can take the survey at any time during or after the webinar. The resource widget contains links to check out our free webinar library and register for upcoming webinars. This webinar is being recorded for your convenience. You'll be receiving an email with the recording link for future reference. Find Applied Software on social media to make meaningful connections, receive special offers, and stay up to date on the newest innovations. And be sure to visit our website, ASTI.com, to see how to achieve your design and business objectives through our innovative solutions, training options, and services. Click the link in the resource widget to register for upcoming webinars and view previously recorded webinars on demand. You can also find a complete schedule of upcoming events, webinars, and trainings on our calendar at asti.com/calendar. I'm pleased to introduce Dave Morse. Dave is a technical support specialist at Applied Software. Thank you for joining us today, Dave. Take it away.
Thanks, Caitlin. I appreciate that. Thank you, everybody, for coming here and spending some time with me this afternoon. Would like to go ahead and share my screen, and if you'll let me know, Caitlin, when you can see my screen.
All right, can do. All right, you're good.
All right, that looks great. All right, again, thank you everybody for coming today. We're going to talk about some data management for building component manufacturers. And we'll talk about some new functionality today that exists in 2021 release of Autodesk software, which is going to include, and what we're going to focus on is Vault and Inventor and Revit. So what we're going to talk about is being able to collaborate with Revit users in our environment in Inventor, but also we'll demonstrate how that would look in a vaulted environment. So we can see how we could utilize Vault and even BIM 360 in our scenario today. All right, so there's 5 areas of focus for our Inventor/Revit interoperability in the building or construction environment, and so generally, people are going to fall under one of these 5 categories. So if we're talking about building products and equipment such as chillers, vertical circulation equipment, things like that, that'd be one category. The next one would be custom fabrication, such as the custom stairs that you see depicted in the picture, or maybe even curtain wall fabricators might be considered under that custom fabrication. The third one, building equipment layout, maybe such as industrial facilities and industrial equipment layout. Modular construction includes prefabricated components and structures in whole or in part, and also the AEC engineering for flow and other engineering design capabilities. So that's kind of the areas that we kind of focus on or talk about when we talk about the Inventor to Revit interoperability. One of the biggest problems that faces the building product manufacturers and contractors in the AEC industry is coordination and rework. Often, your profit margin is linked to the final payment, which is only received once your products are installed, commissioned, and signed off. And this can happen if you deliver your product to site only to find that it doesn't fit or that there are installation sequencing issues. Today, I'd like to show you some new functionality released with Autodesk Inventor 2021 that allows us to reference a Revit project file into Autodesk Inventor to use in coordinating our design with the collaborative 3D design model, the BIM. In addition, I will show you how this workflow is supported by Autodesk Vault 2021 and can even leverage the use of BIM 360 for a more seamless collaboration. The technology behind this workflow is known as AnyCAD, and it allows us to reference CAD files into Inventor from other CAD systems without file translation. This means that the CAD file can be edited in its original authoring tool, and when it's saved, an update will trigger inside of Autodesk Inventor. The benefit is that you can collaborate with designers who are using other CAD tools without having to convert files from one format to another. It also means that you can link the geometry in the referenced CAD file in Inventor, confident that when the AnyCAD file is updated, your Inventor model will update as well. Let's see how this works in the context of the AEC industry. The workflow that we will see in this presentation begins in Revit. We're going to imagine that the architect wishes to share their Revit project file with us. We will represent the solar shading contractor who will be supplying the window awnings. The Revit project file can be shared simply as a file or via BIM 360 docs. With Project Sync in Autodesk Vault, we can establish folder synchronization with the Revit team in order to consume the Revit model into Vault for use inside Inventor. In Inventor, we have a manufacturing model of the awnings with all drawings and parts list ready. The Revit project is referenced into Inventor, and the architect's design intent awning models are replaced with our manufacturing model. This guarantees that the manufacturing model is coordinated with the design model. When the manufacturing models are positioned and sized correctly, we will see how they can be exported as a native Revit or BIM neutral IFC file for further coordination and review. Most importantly, we will see how any changes made to the Revit project file will update inside Autodesk Inventor to save time on model updates and help us keep the design and manufacturing details in sync. Let's start here in Revit. This Revit project file is pretty small by Inventor standards, but it still contains a lot of detail that we simply don't need. Thankfully, the designer has created a view of the model just for us called 3D Exterior Solar Shading, in which they have filtered out a lot of the components we don't need. Let's focus on the item we are going to be working on. It's the awning that is built into the curtain wall. As you can see, the design model of the awning is pretty simple. There's just enough information to define its performance and demonstrate the aesthetic of the solar shading solution. In our imaginary scenario today, it will be our job to develop the awning design for manufacture. Okay, let's move across into Inventor. Before we reference the Revit model into Inventor, let's take a look at the awning itself. In Inventor, we've developed our awning design with all the information we need for manufacture and installation, including a bill of materials and drawings, including installation drawings and manufacturing details. We've built this model using a technique called iCopy, which allows the model to dynamically resize to suit our inputs. iCopy will copy the drawings along with the model to save us time when we come to prepare this project for manufacture. We'll assume that this isn't a one-off design, but a solar shading system that we want to reuse across multiple projects. So we've prepared this model using iLogic, which allows us to configure the design within the system scope. For example, we could alter the depth or angle of the awning, or we could alter the number and size of slats. We've also added the ability to control the detail level of our assembly. The AEC team does not want our fully detailed manufacturing model in the coordinated BIM any more than we want the entire Revit model. This helps us to set the level of detail of our model appropriately to the requirements of the BIM execution plan of this project. I'd like to pause here and point out that a possible workflow is to bring the Revit model into Vault by using Project Sync technology to import the Revit model from BIM 360. So we'll take a look and see how this might look. I'm going to switch over to my BIM 360 login, and you can see here that I've got a folder called my AnyCAD demo, which I'm demoing today, and here I have a Revit model from the architect. So this is their BIM 360 site, and I've been invited to that and can log in and see that. What I would do from a Vault perspective is I would set up a project sync synchronization in Vault using the Collaborate tab, and I would configure Cloud Drive mapping. You can see here that I've got one set up here that uses my my folder structure in Vault and is mapped to the Cloud Drive folder on the project. You can see there that it's the AnyCAD demo site. And so I've set up synchronization schedule, and I can also manually synchronize my files. So this is a great way to be able to get files shared over to your Vault inside your firewall from a client or your Revit team, and be able to utilize that design for the manufacturing. All right, so I'm going to swap back over here. All right, so it's time to reference the Revit project file into Inventor. We can start here with an empty Inventor assembly file. We'll go up to the ribbon menu and look on the Assemble tab for the Place tool. We'll pick on Place Imported CAD file. We can now browse to the Revit project file that we wish to reference into Inventor. As the Inventor AnyCAD dialog opens, we'll be presented with a list of saved views that are available within the Revit project. We'll pick the 3D exterior solar shading view from the list and click OK. The Revit project is inserted into the Inventor assembly file just like any other component. We want to make sure that the coordinates of the Revit project match the coordinates of Inventor, so we'll right-click and choose Place Grounded at Origin. And I'll pause this right here and just kind of illustrate what we would do in a vaulted scenario. The Revit model would be brought down to our local user's workspace using the get command in Vault. So swapping back over just to kind of get a feel for how that would look in Vault. We could take that Revit model here. We can see I already do have a local copy, but if I didn't, I would right-click and do a get to get that file to my local workspace so that then it would be available to use the Place Imported CAD file command. If we move our attention over to the browser, we'll see that the inserted Revit model has a small blue arrow icon. This indicates that the Revit model has been linked into the Inventor assembly using AnyCAD. If the Revit file is updated, the inserted Revit file will update inside Inventor. We'll see how that works later in this demo. As we browse the model tree, we'll see how the Revit model is categorized, and we can drill down to the elements we are interested in. Let's find the awnings from the architectural model and hide them so that they can be replaced with our manufacturing model. Here we are back in our Inventor assembly model. I've skipped forward in the process, and you'll see we've already placed some of the awnings. Let's see how it's done. As we mentioned earlier, our awning design is built as an iCopy model. So we'll move up to the ribbon and look on the Assemble tab, Pattern panel, and click on the little black arrow to find the iCopy tool. we can browse to our iCopy assembly, select it, and pick Open. Our iCopy design has been built to use 3 reference points to control its size and position. We've used the Revit model to position these reference points, and we can pick them here in the browser. Let's pick West Elevation Level 3, Panel 2, top left point, top right point, and bottom right point. Now that our design is sized and positioned, we'll click Next, and we have the option to copy or reuse components. We'll go with the default, which is to copy components that are unique to this design and reuse library components such as nuts and bolts. We can click Next again, and we will see the final set of options, which allow us to choose where we want the new files to be saved and what we want to call them. We'll go with the defaults and click Apply to insert our design. Well, that's pretty cool, but it still seems a little laborious, so I wanted to show you a quicker way to place iCopy components using a pattern. We'll start the iCopy tool again and choose our iCopy awning design, but this time we're going to switch to the Feature Pattern tab. The iCopy tool is looking for a pattern of points to use as an input, so let's find one. We'll browse down to South Level, Level 3 panels and pick the top left, top right, and bottom right points just as before. The difference is that each of these points has been patterned using the Revit model as a reference. The iCopy tool will place an occurrence of our panel at each point of the pattern. If we expand the dialog, we'll see that we have the option to place all 4 occurrences or select specific occurrences to place. Just as before, we'll click Next to choose which components we want to copy or reuse, and we'll stick with the defaults for file naming and click Apply. And we get to see the end results. Okay, at this point in our design process, let's imagine that we've received a change order from the architect for the west facade. It happens all the time on AEC projects. It turns out that the position of the stub wall on the north end of the west facade needs to move, which will affect the width of the panels. But we aren't too concerned because we know that our Inventor model is referencing the Revit model. So when the Revit model updates, our Inventor model will update too. Let's see how it works. We'll flip back to Revit here and switch to a saved view of the wall that needs to move. The wall is selected. Its position set from the end of the curtain wall, and we'll imagine that the 11-meter dimension needs to be changed to 12 meters. The model is updated in Revit and saved. As soon as the model is saved in Revit, we will see the lightning flash symbol appear in the Quick Access toolbar in Inventor, indicating that there is an update available. Now, in a vaulted scenario, we would receive the updated model through Vault's use of the project sync with BIM 360. So we'll only know that there's an update needed once we receive the updated model in Vault. In Inventor, we'll click on the Update tool to update the referenced Revit model. Inside Inventor, our manufacturing models of the awnings will automatically update using the coordination points that we referenced from the Revit model, saving us time, but more importantly, reducing the need to check and coordinate our designs before they can be reissued for approval. And of course, a change in Inventor will update everywhere. Bill of materials, drawings, and manufacturing information are all updated, reducing the time it takes to prepare this design for manufacture once approval is received. So, to recap, we've brought in a Revit model into Inventor and replaced the simple design intent model of the awnings with our manufacturing details. If we open up the bill of materials here, we can see that we have a complete list of components and materials to produce and manufacture. We can open the drawing for this assembly to see the awnings in their locations, along with a list of material quantities and procured components. We have everything we need to send this design to manufacture. But before we do that, we still need to go through the coordination and approval process. One advantage of the BIM process is that we exchange the 3D model rather than just the 2D drawings. But before we do that, let's think about our customer for this model. Now, you remember that the architectural designer does not want our fully detailed model for the purposes of coordination any more than we wanted the full Revit model inside of Inventor. Using the iLogic we built into our panel designs, we can configure our assembly ready to be exported for a BIM project. We can click on the button to open our iLogic form as before, choose medium detail level, and watch the changes cascade throughout the model. Fixings and their holes are removed and features are simplified to leave only the detail required for coordination. You'll notice that we have prepared this model to show a number of other changes that can be controlled top-down using iLogic. The awning depth and the angle and the number and size of slats can all be controlled from the top down, allowing us a degree of flexibility should there be a revision in scope. And then finally, we'll hide the referenced Revit model so that it doesn't get included in our export. Now that we've prepared the design for coordination, we can export it as a BIM object. We'll go to the ribbon looking for the Environments tab, Begin Panel, BIM Content button. The first step is to author the BIM object. This simply means adding metadata to help identify the object in the BIM. Let's click Author Building Components, and we'll see the information we can add. At the top of the dialog, we'll see controls for orientation and insertion of our design. We don't need to worry about these because our design was built using the Revit model's coordinate system. Next, we'll see classification. We can click on the folder icon to search the Omni class tables for the correct classification for our BIM object. Next up, we can add identity data such as our company name, website address, and design details. By clicking on Model Properties, we can add information from our model, including physical properties and custom properties that can be used to map to BIM standards such as COBie. Now that our model is authored, we can export the model to a BIM format. We move to the Publish panel and click Export Building Components. We have the option to save this file as a Revit family, Autodesk Exchange file, or neutral BIM format IFC. In this case, we're going to choose an IFC file so that our design can be linked directly into Revit using the shared coordinate system, where it can be coordinated with models from other contractors. When the export is complete, we upload the file to Vault and then use Vault's Project Sync to upload the IFC and any other documentation to the Revit team's BIM 360 site. So we'll flip over and take a quick look at that as well. So coming back over here to Vault, we can see that we have a folder structure here for exported files. We can see that we've exported more than just the IFC file, which you see here, but we have an RFA family. We have some HTML documents that go along with these exports. We have the Revit, we have a Navisworks file. And so we have all the files that we might potentially need for export. So what we can do is we can set up through the administration Vault settings under our Collaborate tab. We can configure, again, another cloud drive mapping and synchronization. So we could call it Inventor Export, and we would select the Vault folder that we want to use to synchronize. So we're going to set up this mapping, and we're going to map the exported files, and then we would select the cloud drive location. You can see there's the BIM 360, and I can go to my site and I can select, where I want to place that project file. So I'm already using the AnyCAD demo in my other synchronization, but I'm using a different folder structure from the Vault here, so I'm still going to place it in the AnyCAD demo folder. I can enable manual sync, and I can also add a schedule for this. So again, I'll select the folder for my mapping. And what do I want to do is the action. Do I want to upload to the cloud drive, download from the cloud drive, or do bidirectional? In this case, I only want to upload. I'm not going to be consuming anything from the BIM 360 side, so I want to just upload to the cloud drive. And of course, if there are potentially going to be subfolders, I could check the boxes for apply the selected action to subfolders. And if there's any hidden files that also need to go along with this that need to be synced as well, I could certainly check that box. I'm going to leave that unchecked for now. Click OK. Once I have that folder path, notice that it's not scheduled. So I'm going to go to the Schedule tab, and I'm going to specify when I want that synchronization to occur. So if I want to do it daily at 12 a.m., I could do that, or I could do it every so many hours. The minimum for this is an 8-hour synchronization. Here at Applied Software, we actually have a tool that we've developed called 360 Sync, which can synchronize not only from Vault to BIM 360, but across multiple platforms such as Dropbox or Box, and Vault and BIM 360, and a plethora of formats and platforms. And one of the functions that it has is the ability to set a much tighter synchronization schedule than what Vault out of the box will provide. So we do have that. Plus, there's manual synchronization that you can enable here. So my schedule is set. I'll just leave it at daily at 12 and click Apply and click OK. And so I now have that mapping set up and that synchronization set up. So now I could, select the folder or the files, and I could, synchronize those files across to BIM 360. So here we have the upload to cloud drive. So I can upload files to a selected cloud drive destination or download from cloud drive and so forth. So that's how that would look. All right, swapping back over here to our presentation. It's worth mentioning at this point too that the product design and manufacturing collection also includes Navisworks, which is often used in the AEC industry as an on-premise coordination tool. If you're required to supply a Navisworks file as a project deliverable, it's as simple as opening the Inventor file in Navisworks, saving the file, and issuing it for coordination. Alternatively, your IFC or Navisworks file can be uploaded to BIM 360, which provides model coordination and review tools in the cloud. In addition to this, Vault 2021 actually provides new preview capabilities for Navisworks files that was previously not supported. So that's another indication that the data management component is moving forward with the interoperability components between Inventor and other products such as Revit and Navisworks. So let's recap. We saw how we can link a Revit project file into Inventor using AnyCAD to act as a reference to allow us to size and position our manufacturing models and coordinate our design with the architect's design intent. We saw how the link is live, allowing the Revit model to be updated in Revit, and have the reference model updated in Inventor, updating our manufacturing model to suit the revised design automatically. We saw how we can export the manufacturing model from Inventor and complete the round trip back into Revit for coordination and approval. So what we've discussed today is a very specific workflow between Revit and Autodesk Inventor, including Vault and BIM 360. Obviously, there's a much more to building products and equipment than just coordinating the design. What we haven't had time to talk about is Autodesk Inventor as part of the product design and manufacturing collection, helping you with the end-to-end workflow from initial concept design through to the manufactured product, supported by data management in Autodesk Vault and process management in Fusion Lifecycle. The collection includes the design and automation tools in Inventor, plus advanced simulation for testing your designs, nesting, and 2.5 to 5 axis CAM for manufacturing output, and factory layout tools to help you optimize your production facility. It's an end-to-end solution that works right inside Inventor, along with complementary tools like AutoCAD, Fusion 360, and Vault. So if you're getting involved in BIM projects and evaluating ways to improve your development process in any of these areas, we'd love to discuss how we can help. And that's it for my presentation today. If there's any questions, we can take those now at this time. Caitlin?
I'm sorry, I was muted. Thank you very much. That was wonderful. It was a very informative presentation. Yeah, I don't see any questions, but if anybody has any questions, you can contact us at asti.com. You can contact Dave through the links that are on your page. So yeah, thank you everybody so much for joining us today. We appreciate you spending your time with us, and we trust that it was meaningful and impactful for you and your business. We look forward to seeing you on a future webinar. Thanks, everyone.